Hey again, everyone. Thanks for opening up your Science Sketchbook. On this page, we're going to be talking about a simple system for converting a molecule from its bond line structure to a Newman projection. Looks like Sketch has a bark reminder for you. Remember, that stands for background and review knowledge. That's basically just some recommended information to brush up on to feel prepared for this topic. So Sketch suggests taking a look at some IUPAC nomenclature. At this time, just a basic understanding of how to number a molecule and recognizing some simple substituents. So let's talk about Newman projections. They're basically just another perspective of looking at a molecule. You're used to the regular bond line structure shown there on the left, but imagine that you just picked it up and twisted it out towards yourself. So now in the Newman projection, the sort of crossing over lines there are the front carbon, and the wide circle in the back with extra lines coming off of it, that represents the back carbon. So if it's a little unclear, Sketch will give a demonstration. So see how it's kind of like viewing his side view or a profile and having him turn out to face you. So that exact concept is seen with these molecules when we put them in a Newman projection. So if that didn't resonate with you too much, you can see this in the ball and stick model. So notice how that red carbon on the left there got kind of pulled up forward and goes in front of that back blue carbon. All right, so let me show you a 3-step method for drawing a Newman projection from a molecule in this example here. Step 1, right away, you need to see which carbons you are looking down, right? This will tell you which carbon is in front of the other. So basically the side that will be turned out towards you. It'll be written in this format like C2 to C3. So this is where that IUPAC numbering is helpful. The carbon numbers given correspond to the properly numbered parent chain using the IUPAC system. So here, highlighted in red is carbon 2, which will be the carbon in front, and highlighted in blue is carbon 3, which will be the carbon in back. So that means we are looking down the barrel of the carbon 2 to carbon 3 bond, so to speak. Here's kind of an idea, like as if you were looking right at that and behind it is the blue carbon, for example. All right, so that's step 1 done. Step 2, you're going to find a Y shape on the front and back carbon. This will make a little more sense when I show you it highlighted on that molecule, but take a look at those 4 Newman projections there. So notice how the red or front carbon just kind of looks like a regular right side up letter Y on that top and the right Newman projection, but it can also look like an upside down Y, like the ones on the left or the bottom. So that's basically what you're going to be looking for. You'll notice that when you highlight your molecule. Also important to notice is that see, some of those Newman projections look kind of spread out or staggered, and others look like they're kind of blocking each other or eclipsed. Those other types of conformations will also become apparent when you compare how your front and back carbon look. So here, now we can kind of visualize what I mean. So take a look at that front red carbon. I was able to highlight this shape that does look like a right side up letter Y, yeah? So that'll be the orientation of the front carbon. Now compare that to this blue back carbon. The Y shape looks kind of upside down. So that'll be the direction it's facing in the Newman projection as well. So remember that the back carbon is represented with this sort of wide circle that will be included in the Newman, but ultimately notice how it's still an upside down Y shape there. All right, so just overlap those two, and there you go. That's the basic orientation of your Newman projection. So you've got a staggered shape here, and you're ready to go. So the parts of the Y shapes will directly correspond to where you put things on the Newman projection. So look at the stem of that front red carbon, right? So that Y in the front, it's got a CH3 there on the stem. So it goes on the stem of that Y. And then the back blue carbon, for example, it also has a CH3 or methyl group on the stem of that Y, just upside down. So that's why those two things, those methyls, both go like on the vertical lines of these carbons. All right? So now, finally, we need to see where the other atoms end up. Will the wedged OH there go on the left or right side of the Y when flipped, for example? Well, that is step 3. When you determined you were looking down carbon 2 to carbon 3, notice how that it looks like you're looking down the left carbon to the right carbon, as shown with the arrow there. So to get it right every time, use this little mnemonic, because trying to figure out the perspective or redraw it can be a little confusing. So basically, if you are looking from left to right, wedges are on the right. And if it was from right to left, then wedges are on the left. So in this case, our front carbon is on the left, and so then we continue to the right, so that's left to right. All of our wedges will be on the right in that green circle there that I show. So those wedges, both OH and fluorine, should be on the right side of the Newman projection. So you can view that here. So there, for the front red carbon, we've got our wedged OH, so that's on the right side. And for the back blue carbon, we've got our fluorine, and it is wedged, it goes on the right side, right? So thus, that just leaves the last ones, the dashes, to fill in the other side as well. All right, so there you have it. With all that mess out of the way, this is what the conversion looks like in those 3 steps. Now, this is a perfect little example where everything is drawn out for you. But, you're not always going to have every single hydrogen and things drawn in to see those nice Y shapes. So what about if you are missing wedges, dashes, bond lines, or anything implied there? Well, you just have to fill them in. That way, the Y shape will become apparent to you. So let's think of those steps. Step 1, let's see down that C2 to C3 bond again. So notice, though, that the position is a bit different from the previous example. Again, don't just blindly count left to right. Ensure that it is the IUPAC numbering system. So because we typically want to number in a way that gets our substituents a lower number, that's why we counted from right to left in this example. All right, so that's step 1 done. That red carbon 2 is our front carbon, and the blue carbon 3 is our back carbon. Now, for step 2, remember we have to draw in our Y shapes. So I attempted to place it here, but we are missing an atom to fill the shape, right? Well, it's just an implied hydrogen. So go ahead and add it in. If you remember from, your bond line lessons, carbon likes to have 4 things coming off of it. It only had 3, so we knew we needed that extra bond drawn in with hydrogen. So the same thing is going to go for the blue carbon. We only had the one stem or the stick of that Y shape, but we needed to add the little prongs of that Y, if you will. So, of course, that carbon has 2 things coming off of it. It needs 2 more, so those are its implied hydrogens. So, just as a note, notice that wedges and dashes will be drawn adjacent to each other, and opposite of them will be the planar lines. All right, so we see that the red carbon, it's a right side up Y. The blue carbon, it's an upside down Y, so if you overlay those 2 shapes, we get this other staggered form yet again. All right? So to finish off step 2, we see that the stem of that Y shape on that front red carbon is CH3. So that just wasn't drawn in because remember, any end of a line or dead end equals a carbon. So just keep that in mind. So for the back carbon, it might be a little bit trickier, right? The stem of that Y has the rest of the carbon chain. So you just kind of write everything else in with just its molecular formula. So given that it's a CH2, CH3 coming next, you can just write it in that condensed form instead of trying to draw an extra Newman projection on your Newman projection. So now we're on step 3. We need to figure out which side our wedges and dashes are going on. So remember that mnemonic I gave you. Left to right, wedges on the right, and right to left, wedges on the left. So since we're looking from the right carbon to the left carbon, our wedges will be on the left. So that means for our front red carbon, that methyl group will be on the left of our Newman projection. For the back carbon, it is the same situation. The wedge will go on the left of the Newman projection. Since they're both hydrogens, it didn't really matter this time, but just for good measure, I still highlighted which of those hydrogens went on the left side. So the dashes just end up on the opposite side there on the right, and we're good to go. So again, with all of that out of the way, we can see how this plain-looking molecule ended up as a staggered Newman projection as shown. So let's try just one more example where we have some missing pieces. So look at this 4-carbon chain. It's just a butane with nothing on it, so you can just number left to right in this case. Perfect. Now that we have those numbers, we can pretty much finish off step 1. We know where our front carbon and back carbon are now, so why don't we try this example a little more rapid fire? All right, step 2, find those Y shapes and fill in any missing implied hydrogens or carbons that you should label for later. Go ahead and do so for both the front and back carbons. Now, take a look. It looks like they are both in the upside down Y shape. This means that we are likely going to be looking at an eclipsed Newman projection for this example. So for our front carbon, all right, the stem of our Y shape gets our CH3, and then we get to put our mnemonic to the test again for step 3. So we were looking from left to right, and that's wedges on the right. So that wedged hydrogen highlighted there goes on the right side. Of course, the dash there also had a hydrogen, so in this example, if you got a little tripped up, you might have accidentally gotten the right answer anyway, so that's good. So the same is going to go for the back carbon. So notice how everything was all stacked and eclipsed here, right? They're all kind of squished together. That's because they're both upside down Y shapes. Other than that, everything else works the same. The stem of that blue Y is the hydrogen. And again, we were looking left to right, so wedge is on the right. Thus, your wedged hydrogen highlighted there is on the right side, and that methyl group got the opposite side. Now, with everything out of the way, you can see how a very simple molecule was turned into its Newman projection here. So I think that was plenty of example problems, right? So before we practice, let's recap those 3 steps I kept mentioning about how to convert to a Newman projection. So step 1, find what bond you are looking at. I did C2 to C3 for these examples, but it really can be any 2 adjacent carbons like C1, C2, or C3, C4, for example. All right, step 2, highlight those Y shapes on the front and back carbon. Fill in any missing implied hydrogens and things first to really see that shape. Keep in mind that one right side up and one upside down Y shape would be a staggered conformation, while 2 of the same orientation would end up being an eclipsed form. So of the Y shapes you end up highlighting, keep in mind that the stems of those Ys will also translate onto the Newman projection, just on the vertical lines. Now for step 3, we have that mnemonic that can help us know which side our wedges and dashes will go on. If you're looking from the left carbon to the right carbon, wedge is on the right. So left to right, wedge on the right, right to left, wedge on the left. All right, with all those steps in mind, why don't we try out some practice problems? For each molecule, you can draw the Newman projection down the C2 to C3 bond. So Sketch suggests you pause your video here to give it a shot before we discuss the answers. Alrighty, so here is everything. I made sure to draw in the relevant implied hydrogens, and I highlighted the front carbon with a red dot and the back carbon with blue. So looks like you've got mostly staggered Newman projections here and just the one fully eclipsed one. So pretty unstable one, right? The second one there. So yeah, as long as you correctly labeled your front and back carbon and correctly found which side your wedges and dashes will go on, then looks like you did it. So amazing work as always. Feel free to let me know how many you got right. So you've just made it through this page of your science sketchbook. If you want to learn more, of course, you're always welcome to check out any of the other videos on my channel. But other than that, that's it for now. I will catch you again soon.